Okay, so maybe we can start. Hopefully, more people will join. So good evening, good morning, everyone, depending from where you are connecting, and thank you for joining us for this session. So this session is organized, this seminar is organized under the Division C of the IU, the International Astronomical Union. And the Division C stands for the education, outreach, and heritage. There are different commissions that are there related with these three fields that I mentioned. And under the commissions that we have, there is also Commission C1 that is focused on astronomy education and development. My name is Mirjana Pović. I currently serve as Vice President of the Division C. And under the Commission C, as I mentioned, the International Olympiad on Astronomy and Astrophysics is one of the activities that are running. So we have here Anike Zule, who is a professor researcher working in India and current president of the Commission C1 and then the International Olympiad on Astronomy and Astrophysics. We have Professor Nataša Dragović, who is originally from Serbia, currently based in US, and she's currently the General Secretary of the International Olympiad. And then we have Professor Greg Stachowski, who is based in Poland, and he's the past president of the International Olympiad. So the idea behind this training, this seminar, is to give you more information about the Olympiad, how it works, and then to motivate more countries to join and to participate in the Olympiad. It's a great way to actually motivate, inspire our secondary school kids, teachers as well, to continue with their education, science, and to promote STEM fields as well. So welcome everyone, and I will now give the words to our colleagues, Aniket, Nataša, and Greg, to start with the seminar. I will turn off my video because of the power and internet problems here on my side. So thank you very much once again to all three of you for giving the seminar, and then to all of you who joined. And if you joined a bit later, please put in the chat where are you based, from where you are connecting, so that we can see a bit what is the geographical distribution of the participants. Okay, thank you. And yes, the floor is yours, Aniket, Nataša, and Greg.
Thank you, Mirjana.
Thank you.
I will just share the screen. Okay, so I hope everybody can see this shared screen.
Yeah.
Okay. So as Mirjana just introduced, we, Aniket, Greg, Nataša, together we represent the IOAA, and some of us are also members of IU Division C. And we thought it will be a good opportunity for to welcome newer countries to IOAA. So this is what we are going to do is we will share the talk with different parts. Let me start with just a brief intro of who we are. Currently, the International Olympiad on Astronomy and Astrophysics, IOAA, has this executive council. I am the current president. Nataša is the current general secretary, and we have three councillors. Greg was the president before me, so he's immediate past president. And we have two more councillors. One, Gustavo Rojas from Portugal, and Sirama Komunjita from Thailand. So just before I hand over the session to Greg, I just want to say a few things about Olympiads. Uh, if you look at what International Olympic Committee says the purpose of Olympics is, it says, so in their charter, you will see the goal of Olympic movement is to contribute to building a peaceful and better world by educating youth through sport, practice without discrimination of any kind, and in the Olympic spirit, which requires a mutual understanding with the spirit of friendship, solidarity, and fair play. So, based on the same principles, so there are academic Olympiads running in several subjects. So, for example, you can have Olympiads in multiple different disciplines. There are Olympiads which are in mathematics, in physics. These two are really biggest Olympiads, are also the oldest, but there are also Olympiads in chemistry, biology, informatics, earth science, linguistics, and many more. Why educators would like to participate or form an Olympiad? There's some academic reasons. You want to encourage the participants and the students to be their best, give their best effort rather than defeating others. We would like to challenge the students to think beyond their regular curriculum and encourage them to learn new things. We would like to channel national competitiveness, which we find, to positive ends. And we would like to introduce people to latest research happening in the field. There are also other reasons, like we want to give the students opportunity to meet other students who are just like themselves, and also enable them to visit places which are very different from their home. So based on these ideas, we have defined mission of the IOA as the main. So I'll just read out. The main goal of IOA is to promote the growing interest in astronomy and related STEM subjects, especially through general education of young people, and enhancing the development of international contacts among different countries in promoting astronomy and astrophysics in schools. It is expected that through events like IOA, more bright high school students will be eager to study astronomy at university level to become next generation of astronomy and astrophysics professionals. IOA presently is fairly large. This was the group of the different team mentors which participated in IOA in Brazil just 2 months back. It was August 2024 was the last IOA. And this is a picture of all the participants, students, as well as mentors from IOA Junior in Nepal in 2024. So what these events are and what is mentors and all these things, I would hand over to Greg. Greg?
Yep. Are you going to keep sharing the screen?
Yeah, sure.
So I'll tell you when to go to the next slide then.
Okay.
Okay, so thank you, Aniket. And what I'll do now is give you an overview of how the IOAA works in practice, how it's organized, what kind of things go on, and how it impacts the participants and the wider community. So let's start with the timeline. Aniket, next, please. Thanks. So each IOAA, so far we've managed to have one every year, except for during the COVID pandemic when we had an online version. Each one lasts for about 10 days, and it involves the participating teams traveling to the host country. What a team consists of, I'll get into in a moment. But for now, just be aware that a team consists of the students who are participating in the actual event and accompanying adults who we call team leaders. We can also call them mentors. During the IOAA, they are accommodated separately so that the students are not in any position to become accidentally aware of what the competition tasks are or communicate with the team leaders or with some kind of outside party that might influence the event. In the meantime, the mentors review the question papers which have been prepared by the local organizers. They will translate them into the local language of their team. So we don't require that the students know English, although in practice most of them will have a decent grasp of English, but it's not required. And then the students take part in the competition rounds, of which there are a number. During this event, the students will, of course, have full accommodation, food, they will have free time, they will have excursions in between the events, and they will be transported to wherever the competition rounds are taking place, if that's necessary, and on the excursions and so on. The marking process for the students' work takes place in parallel. There is a local jury which grades all of the questions, but also the mentors for each team grade their own students' work. And at the end, we confront the two sets of results in a process which we call moderation, where if there are any doubts or inconsistencies in the marking, these can be resolved during mostly peaceable discussions. And this avoids issues where maybe the jury has misunderstood what the team has, the student has written, or a piece of paper has been lost somewhere, something's been lost in translation. Any kind of issues like that can be ironed out to ensure that the grading is fair. And then at the end we have an awards ceremony where medals and other awards are decided. So thank you. The participating teams, we had to come up with a way of deciding how we allow teams to participate, and the simplest way to do that was simply to roll with whatever the International Olympic Committee decides. So any country or territory that is recognized by the International Olympic Committee and can participate in the Sports Olympics can also send a team to IOAA, and this avoids the kind of questions that might sometimes arise if there are issues with sovereignty or some kind of breakaway regions or other things like that. So we just farmed that out to the IOC. They can deal with it. They've had practice over a century. The teams consist of up to 5 high school students. We require that the students were still in high school at the beginning of the academic year, at the beginning of the year, calendar year, in which the IOAA takes place. Obviously, in different countries, the academic year starts and ends at different times of the year. So it's very difficult to just place a hard cutoff that they have to be in school, on 1st September or whatever it is. So we just say that they have to still have been in school at the beginning of the academic year, and they should not be more than 20 years old before June the 30th of that calendar year. Again, to accommodate the various differences in when school attendance happens in different countries. And generally this works quite well, and this is also a scheme which is used by the other major Olympiads that Annika mentioned, the Physics Olympiad, the Informatics Olympiad, the Chemistry Olympiad, and so on. So it's consistent with that. As I mentioned, the team is accompanied by 2 adults, which we call team leaders, and they have the dual role of firstly looking after the students during the travel phase, and also discussing the problems during the meetings, translating the problems, marking the students' work, and so on that I mentioned already. As a breakdown of where the mentors come from, the vast majority, maybe 60% or so, are professional astronomers of some sort. So usually university academics, research astronomers, that kind of thing. The next largest group are teachers, usually physics teachers, since astronomy is not taught in schools often, but teachers with an interest in astronomy, often teachers who run the astronomy club in their school or are otherwise involved in astronomy outreach in their community. Dedicated outreach persons. So here, amateurs who do outreach, people who run astronomy clubs, astronomy societies, people who work in planetaria. That's the next largest group. And increasingly, we have seen past participants coming back as team leaders. Sometimes they are coming back as members of one of these other groups as well, as professional astronomers or teachers or outreach professionals. Sometimes they're coming back just as university students who are still studying astronomy but want to come back and participate in the IOAA as a team leader. There are a large number of other people who are involved in the IOAA and who participate. In terms of visitors from outside, other mentors, shall we say, can come as observers. Sometimes they'll come as people who are accompanying the team. Sometimes they'll come because their country is looking into participating in a future Olympiad and they want to see how the process works and learn. There can be members of, for example, national astronomical committees. There can be members of the funding agencies. There can be Ministry of Education officials who come in these kind of roles. But also we see the family members of team leaders or observers visiting. We have very occasionally, although we do try to discourage it, the parents of some of the participants also coming and staying during the time of the Olympiad, particularly if there are students with maybe special needs or younger students. Sometimes the parents will want to be not too far away in case of anything happening. The host countries can invite a second team as a guest team, depending on the availability of space and the accommodation. And the rules of eligibility are the same as for the main team. In the final results, these teams are labeled as guest. This has become less and less common as the size of the Olympiad has increased. And obviously, we will always try to accommodate the main team from each country before opening up any additional places to guest teams. So I expect in the future there will be fewer and fewer guest teams. But sometimes a team has the resources to send a second group of students, maybe a younger cohort, to the IOA to experience it. And there are mechanisms for that. And finally, a very important part, which sometimes gets forgotten, is the local participants. Obviously, there are the organizers. There is the jury who marks the questions. Typically, jury members are PhD students or younger academics, people who are well versed in solving these kind of problems, and they're drawn into participating in that way. But sometimes there are also amateurs, outreach professionals, teachers, and so on. But also, and I've highlighted these, there are two, I think, very important groups which are relevant to taking the IOAA and the astronomy out beyond just the community of astronomy educators or astronomy students. And that is firstly the team guides. These are local young people, usually undergraduate students, who are assigned to each team as a local liaison. They will stay with the students of that team, and their job is to ensure that the students' needs are met and that the students are always where they're supposed to be when they're supposed to be there. And we don't require these team guides to be astronomers. In fact, we prefer that they're not. We want them to be students of all kinds of other fields, so they can get a feel for astronomy, get a feel for the whole event and all these kind of things. It's common for these students to be students of languages represented by the team. So, for example, a student who is studying Chinese might join as a team guide and be assigned to the Chinese team, and they get 10 days of practice with the, practicing the language with the Chinese team. And the students from the team are happy with this. They have somebody that they can talk to, somebody who's looking after them, somebody's more their age to interact with. And the team guides get this experience, which is completely unique and outside of any kind of other experience that they might have had. And the other group are telescope assistants. For the observing round, which I'll discuss later, we often need a lot of people to ensure that any telescopes, for example, that are being used are set up correctly, calibrated, that anything that needs to be reset is reset for the next round or for the next student. And there just aren't enough organizers to do this. So the standard way to do it is to grab a group of amateur astronomers from the local astronomical community, amateur community. And again, we're reaching out beyond the academics into people who maybe are not academic astronomers, but who are amateurs and who know telescopes. And this can be a considerable number of people. Typically in a current IOA, this will be maybe 100 people or more in total for these kind of local participants. Okay, so the Olympiad itself is broken up into rounds. And the idea here again is, I mean, we think of the Olympiad as a competition, but it's more than that, as Annika had mentioned. We're trying to find ways in which the students can express their interest in astronomy in different ways. And we know that not everybody is good at every kind of thing or one kind of thing. So there are different rounds. In terms of the individual competition where the students are competing as individuals, solving problems, there is a theory round. This is classical, almost school type problems, solving equations, calculating numerical results and so on. Natasha will explain all of these kind of things later on when we get into the syllabus. This takes up about 50% of the total result of the individual part of the competition. Then there are two rounds which together form what we call the practical round, and the practical round again takes up 50% of the total score. That's why I've bracketed them together. The first part of that is the data analysis round. And here it is what it sounds like. We give them data and they do analysis on it, maybe some simple statistical analysis, maybe some graph plotting, and try to get conclusions from that. The important thing which we emphasize here is that the data analysis round uses real data. This is not massaged data that you would find in a school textbook, school curriculum. We actually go out and we find real data from real observations, which the students then analyze. Obviously, we make sure that it's presented in a way that they can understand and manage, but it is real data that they're using. And the final part of the individual part of the competition is the observation round. And this, because it's very dependent on the local resources, it can take many different forms. It can be in a planetarium, it can be at telescopes, it can be simulated, it can be real under the night sky. It involves sky maps, planning, observations, all sorts of these kind of things. Doesn't even need to take part at night, although almost all of them have taken part at night, place at night. But there's a lot of freedom in terms of what the host can organize. And then we move to the collective part of the event, where we have two rounds. We have a group competition round, where the participants, this has evolved over time in terms of how we've done it, but the formula that we've settled on now, and it seems to work very well and seems to be very popular with the students, is that we sort them randomly into international teams, which are then named, for example, after constellations or after asteroids, something non-national. And we give them tasks which they have to perform and solve collectively. These tasks are designed in a way where one person would not be able to solve the tasks in the time available, or even sometimes not at all if they require, for example, two people to set up an experiment or measure something at the same time. So this forces the students to work together, to collaborate, and it's kind of a way of simulating in this kind of high school level environment what real academic cooperation might look like. And finally, the poster round, where we judge and give awards for posters which the students have prepared before coming to the IOAA on various themes. And again, the host has a certain amount of freedom in terms of what kind of themes they might suggest for the students. Next. Yeah, thank you. So these are just quickly a couple of examples. On the right is an example poster. There's a wide variety of posters. This is one from the Korean team presenting the function of a traditional Korean sort of hemispherical sundial. Very typical, but there have also been posters on light pollution, on wildlife, on and more academic ones on exoplanet transits and asteroid light curves. So there's a very wide variety of what the students will do, what they get up to. And the idea here is to encourage them to do things between the competitions, not just, you know, in the week before and when they're there, but all the way through the year, do something involved in astronomy and or relating to astronomy and then present that. And on the left, a photo from last year's IOAA group competition round, and I picked this because the student is holding an astrolabe, and we manufactured astrolabes for the students to use during one of the tasks for the group competition. And here again, there is a wide variety of things that the host country can come up with, and we encourage really encourage the host to innovate and come up with a really almost crazy sometimes ideas for you know what the students can do. And the students really like the group competition round because it's so different to what they do in school and because they have to do it in a collaborative environment. Is this going to play? Yeah, so this is just a quick video. Aniket will play. If you can mute it, Aniket, I think maybe. This is just a quick video, about a minute or so from the night observation round in Hungary in 2019, just to give you a feel of what that looks like. I'll be talking over it. So here we have a sports field set up, and in that grid that you can see there, which we'll zoom into, are desks, and next to each desk is a telescope, and the students will come in. Usually when we have telescopes set up like this, there aren't enough telescopes for everybody, so they'll do 2 or 3 rounds. Depends again on the local situation. And they will be given observing tasks to perform. And they'll have time before they go out into the field to read the questions, prepare and think about what they're going to do, and then dark adapt if necessary. They'll go out into the field, perform their observations. You can see this is an earlier phase during the day when the students were allowed time to just familiarize themselves with the arrangement with the telescopes. And this is during the observation round. Everybody obviously has red torches, so they don't impact each other's night vision. And they're doing the observations, finding objects, making measurements. They typically will have a stopwatch or something and a clipboard. And then after they come off the field, they'll have some time to, you know, do any calculations, whatever, before they submit their final results. So something very different to what you might see in a physics Olympiad or a maths Olympiad or a chemistry Olympiad, something really typically astronomical that you don't get anywhere else. Okay, next. Yeah, so as the name suggests, it's an Olympiad. There are awards, there are medals, but the idea here again is to not have the students competing with each other, but competing against themselves, their own abilities, and where possible, recognizing their effort and their achievements, whatever that is. That doesn't mean participation trophies by any means, but it does mean, you know, giving them opportunities to show what they can do. So next. Yeah. So for the individual competition, we have a scheme where we normalize the scores, the overall scores, and then gold, silver, and bronze medals are given to any student who gets a suitable proportion of points over that that median score. So it's not, we don't restrict the number of gold medals. It's not just the top 3 or the top 5 or the top 20, whatever. Any student that gets over that benchmark score will get a gold medal or a silver medal or a bronze medal. And the honorable mention works slightly differently. It's not a 4th medal, as it is sometimes in some competitions, but we look separately at the theory round and at the practical round. The practical round, again, combines data analysis and observation. And we look separately at those. And if the student managed to get over 50% in either the theory round or the practical round and didn't get any higher medal, then they will get an honorable mention certificate. And this rewards those students who maybe are good at observation, maybe they're good at data analysis and statistics, but they don't have the practice to solve the theory problems. Or maybe they're good at solving the theory problems because that's what they've been doing in school, but they've never seen a telescope in their life and they have no idea what to do with a telescope under the night sky. So again, we're giving people the opportunity to show what they can do, and we're not penalizing them just because they're good in one thing and not good in another. Next. Oh yeah, sorry. And also there are special prizes for the best student in the theory section, in the practical section, the overall winner, for the best poster, and also each member of the best team, and that might be 5, 6, 7, 8 students, will get a prize medal for being the best member of the best team. So overall, a large proportion of students will get some kind of award or certificate or some kind of recognition of their abilities. It's not just, you know, the top 5 teams or something that get something. So that's how it works in practice. Now, a little bit of how things have developed. So the first edition was organized in Thailand in 2007. About 20 exactly 20 countries participated. And it was an offshoot of the Physics Olympiad, the International Physics Olympiad. The previous year in 2006, a group of representatives from 5 teams, Thailand, Indonesia, Iran, China, and Poland, had gathered, had met at the Physics Olympiad and discussed the need for a Physics Olympiad-like event, but more specifically targeted at astronomy students. And Thailand was gracious enough to host the first one. Since then, as I said, we've managed to get one every year. And the last one was in Brazil in 2024 with 53 countries. So you can see that there's been significant growth. And on the left, there are photos, all the participants, student participants from the first IOAA in 2007, and below all the student participants from last year, 2023 in Poland. An enormous growth, and it just shows how much interest there is and excitement there is. Moreover, just going beyond IOAA, IOAA has inspired other events to be organized. First of all, the Latin American Astronomy Olympiad, OLAA, which has been running since 2009, which, as the name suggests, takes place in Latin America. Colombia was the first one to organize this. And this gives an opportunity for students from the Latin American countries where maybe they won't be able to travel to Europe or to Asia because of the distances and the costs, to have an IOAA style event there. And it's not quite the same as IOAA. It's tailored to the local educational needs and requirements, but it's been inspired by IOAA. In Central Europe, so we're talking Hungary, Czech Republic, Slovakia, Poland, neighboring countries, there's a sort of on and off event called the International Workshop on Astronomy and Astrophysics. The mix of countries which take part has varied over time, and it works as a kind of combination practice competition and training camp for IOA participating teams. Since 2022, we've had the IOA Junior, which is for students up to the age of 15, which this year took place in Nepal, and it could show a photo of the participants. And again, this is growing year to year, and it gives an opportunity for students from the younger age groups, younger cohorts to participate. It's modeled on IOAA, but the syllabus is obviously tailored to that younger age group. And finally, a whole series of countries, which I've listed here, and probably not in all of them, have started National Astronomy Olympiads in their own countries, simply because there were students there who wanted to participate in, sorry, I've just had a pop-up from Zoom, in IOAA, but had no local structure to organize a team and train a team and so on. And they've started these events in their own countries, and these events are now going strong for a number of years and producing regular participating teams. In some cases, just one more thing, Annika, before I get to the map. In some cases, this has often been a bottom-up approach. So there are students that have organized this, for example, in Bangladesh or in Turkey. In other cases, for example, in Canada or in the UK, past participants who have gone to those countries, for example, as PhD students or as postdocs, have taken the idea of IOA with them, interacted with local groups, organizers, for example, the local physics Olympiad, and helped organize an IOAA, an Astronomy Olympiad in those countries. Okay, next. So global reach of the IOAA now is considerable. We have quite a lot of regular participating countries. We've had countries that have participated once or twice or three times, but not necessarily participate every year. We've had a number of host countries now, as you can see in green on the map. The big missing piece there, as you can see, is Africa. The only country from Africa which has participated so far twice has been Mali. We almost had participation from a couple of other countries last year and this year, but it didn't come to pass. We're trying very hard to talk to representatives of the astronomical community in African countries, and we've had interest from students in African countries, but so far nothing has materialized as an actual team. So hopefully, I know that there are certain people from African countries here in the Zoom meeting. Please, if you're interested, or if you know somebody who might be interested, if you have contacts, talk to us, Aniket or Natasha or myself. We're more than happy to help you figure out how to organize and come to IOAA. We really would like to see students from Africa also involved, also participating, also experiencing this this event and so on. So hopefully this map will fill in with color over the next few years. Okay, next. So now for maybe the more boring bits, but you should know how the event works behind the scenes. We have a governing structure, as Annika had mentioned, which consists of the executive committee, president and general secretary. There is a formal list of statutes which govern how things happen. And these officials are elected every 5 years. As of, I think, 3 years ago, we also added 3 councillors, who Annika had mentioned, just to ease the workload on the president and general secretary a bit, because the organization has been expanding. The primary decision-making body of the IOAA is the team leaders of all countries, organized in what we call the International Board. And team leaders participate automatically for the year beginning with the IOAA that they participated in. And this means that we're not talking down to the teams, talking down to the team leaders. They are an active part of how the IOAA is organized, what goes into the syllabus, how the events take place, how the awards are given, and all of that. It's a very open and democratic structure. And this was one of the guiding principles when the IOAA was started in 2007, to have this kind of very open structure. And behind all of that, and represented by the team leaders, are the national committees in each country, and they're the ones who are responsible for their team selection process, participation policies, and oversight of what goes on in their national at the national level. And these can be very wide-ranging. We don't really interfere with what's going on there unless we get some kind of information verifiable information that maybe there is something wrong, in which case we will support rectifying that. And we are working towards setting up an IOAA foundation. I think this is well on its way. It will be based in Slovenia, attached to the Slovenian National Organization of Mathematicians, Physicists, and Astronomers, which will manage things like financial issues as IOAA expands, and other things supporting the work of IOAA. And also, as part of this, as IOAA is expanded, we have seen the need, and host countries have notified the IOAA of the need for some kind of participation fees to support the organization process. It's simply becoming too big to just have the host countries supporting it entirely on their own. Financially, which was the case for the first decade or more of IOAA. And so what was agreed is that from next year, there will be a participation fee for the main team, and for observers and guest team members and visitors, which covers basically everything from the moment they arrive to the moment they leave, all of their accommodation, their food, and everything else. And we looked at what the other Olympiads were doing. We looked at what the team national organizations could support, and we reached these numbers as a compromise. These numbers are on the low side if you compare them to what the Physics Olympiad or the Chemistry Olympiad, for example, fees are. They're a lot higher than this. So, but it does give the organizers at least a little bit of a budget, which they would not otherwise have. And also a percentage of these fees will from next year go to the IOAA Foundation to support the work of the IOAA Foundation. For example, travel to IOAA events for the president and the general secretary, and maybe we'll see how these things pan out, but maybe things like financial aid for teams which don't have the funds themselves. So we'll see how that goes. And just almost coming to the end of my part of the presentation, there's a sort of a significant amount of derivative products that the IOAA has produced, which has impacts beyond the events themselves. Obviously, the first thing is the astronomical problems and the problem tasks that we produce. These always have worked solutions. These are translated into local languages, maybe 15, 20 languages by now for each Olympiad, and these are all available. They can be downloaded by any teacher, any astronomy educator, any student who wants problem tasks that they can work on and learn from. There are several problem books which have been collated based on these tasks, with discussions, with explanations, with more details for students to participate, to use, or educators to use as textbooks. We're slowly preparing a new one. An interesting thing that has come out of this is that the team leader of the Bangladesh team has written a textbook in astronomy, and this is significant. He was a participant himself, and he's now a student who will hopefully be beginning his PhD in the near future. And he identified, when he was working with young people in Bangladesh, preparing them for participation in the Astronomy Olympiad, in the National Olympiad, and in the International Olympiad, that there was no textbook in the local language. They're all having to learn from English language textbooks. And he has prepared a textbook in Bangla, which is very good. I've seen drafts of it. It should be published hopefully this year. If it hasn't already been published, I haven't been following the exact details of that, but it's certainly pretty much ready to be published. And IOAA builds community. All of these team leaders who participate, we've all become, almost as Annika showed in the earlier slides, a family. We know each other, we meet each other, not just during IOAA, but at other events. We share ideas, we share ways of educating, and there's a community that's built up. Similarly, the participants, we've seen participants with long-lasting friendships who then go on to visit each other, work together once they join the astronomical community as students or as PhDs, postdocs. Very often I've come up when going to scientific conferences, I'll have a young person come up to me, and this happens almost every conference I go to. Somebody will come up to me and say, "Excuse me, you don't recognize me probably, but I was a participant in IOAA in 2019 or in 2022 or in 2014 or whatever," because I've seen so many of the students, I don't remember all of them, but they remember the team leaders that they were with, or the other organizers that they were with, and they remember these events, and they're enthusiastic enough about them to come up and say, you know, "Hi, I really enjoyed this. This was something important to me." In terms of the organizing countries and the hosts, we've seen improved collaboration between professional astronomers, amateur astronomers, and educators in those countries after organizing an IOA, because the IOA is such a big event and it involves pulling in people to set the questions, to mark the questions, to mind the telescopes, generally to organize the whole thing. Like I said, over 100 people typically, and more behind the scenes sometimes in terms of question setters, for example. It really can bring in a lot of collaboration. We saw this especially in, for example, in Hungary, where prior to the IOA, these were very disjointed communities. Since then, there's a lot of extra interaction between them. Amateurs are going to schools, amateurs are helping professionals observe, professionals are going to schools, a lot of things are happening. And in terms of the host countries themselves, the host cities are becoming more aware of astronomy and what they can do. The team guides that I mentioned, who are often not astronomers, they're aware of astronomy. The jury members, a lot of them will be physics students, not astronomy students. They're becoming more aware of astronomy, and the governments themselves. And in a lot of countries, especially ones with a smaller astronomical community or smaller tradition in astronomy, this can be really significant in terms of support from government agencies for astronomy departments or for astronomy education in schools, or for other projects, because you can point to the IOAA, and frequently we've had ministers or even occasionally presidents or prime ministers visiting Olympiads and really seeing that event happening and the enthusiasm that's been going on. So there's an impact beyond just the educational community or the astronomy community that I want to emphasize. And just the final slide next. The students themselves during the IOA, they have all sorts of things that aren't academic. They have lots of free time, which they can fill with sports, with, as you can see here, they're having some kind of musical event with a bonfire and guitars and singing. We found that the students generally tend to be really outgoing and interested in sharing their culture with each other. And so we have this cultural night.
There's a raised hand. Julian, can we take the question later, or you want to ask something right now?
I mean, maybe I'll just finish with this slide and then we can have the questions for what I've just been saying. And so, like the cultural night, we have this cultural night idea. Initially, we would use we would set up events, maybe a local musical group or something. But over the years, we've come to realize that actually the thing to do is to just give the students a stage and time, and they will entertain themselves and entertain each other and entertain us, presenting their national music or whatever they want to do, and it's fantastic. And also, of course, they're going on excursions, they're visiting local landmark sites and things like that. So there's a huge cultural impact on the students, seeing other cultures, meeting each other, meeting other students from around the world who are also interested in astronomy, which is a really big thing for them. Okay, thank you. That's my part. If we want to question now, I'm happy to take a question, or we can hand off to Natasha.
Yeah,
Julian, you want to ask your question now, or can it wait?
Well, it can wait. Yeah, if you have still more.
So we'll take the question. Yeah, question later. Natasha.
Yeah. So I'll because in the interest of time, I will not be very. I'll be quick. But I just wanted to say I like that there are questions in the chat, so keep writing them, and I think that's going to be good. like now that I'm speaking, if someone else can answer the questions in the chat. But thank you both, Greg and Aniket, and everyone else that is here. So we heard a little bit about how the Olympiad works, but the actual questions, what are they? So I'll first start with what is the general like syllabus overview. You can find on our website on IOAAastrophysics.org, there is a detailed explanation what kind of topics go into all the rounds. But kind of like broadly, I think it was not emphasized enough. So the host country is in charge of coming up with the problems. And so there is a little bit of a national flair, which I think is also a great part of this event. But even though every host has to write their own problems, we tend to see problems from, for example, celestial mechanics. It's like every year there's something, coordinate systems and time, solar system, stellar physics, observation, ISM, exoplanets, cosmology. But of course, because there is a data analysis section, there has been also like, you have to know a little bit about error analysis, and some basic statistics and basic math is also quite required for this Olympiad. And so I'll show you some examples of like theory. Theory, as Greg mentioned, is usually between 10 and 13 questions, but they're not all same length. So there'll be several short questions. So for example, in 2015, we had this question in celestial mechanics, where I'm just going to quickly kind of read it through. So you have a satellite of a planet. So some planet somewhere has a certain orbital period, and we know the semi-major axis is 15 times the mean radius of the planet. You know that the moon has an orbital period of a certain time, and the semi-major axis is certain number times of Earth's mean radius. Assume that the mass of the moon and the satellite is negligible compared to the mass of the planet. Calculate the ratio of the planet's mean density to that of the Earth, right? So it's kind of like your standard like celestial mechanics problem. But then we can have something a little more involved that also references to some other things that are happening in the community. Like in 2023, we saw a problem that talks about the DART mission, about the NASA mission, and it looks into like one aspect of the mission, which is evaluating a method of planetary defense. So how much is this collision changing the period of this asteroid? And so it starts with, part A, where like, what is the expected orbital period change in minutes, assuming, and you're giving some assumptions and you're given some data. And so we can go on to the next slide. And so afterwards, like you're told, okay, you had this like part A, you calculate something, but in reality, what happened? There was a certain change. It was it slowed down by 33 minutes, and then they're trying to explain why did that happen. And so now we're trying to calculate something about this debris that got out of the asteroid. Okay, and then finally part C is you're trying to find the velocity change. So it's like a nice way to kind of summarize like one aspect of this mission. Yeah, thank you. And then we have like finally they're like the kind of like quote unquote hardest problems, because they're quite involved and there's quite a lot of parts to it. But the idea of these problems, the long problems, is that they really walk you through a certain area of either astronomy or astrophysics. So for example, in 2018, we have a whole set of questions about this Friedman's equation. And by the way, the students, they don't necessarily have to know derivatives and calculus, but they are given enough information to work with in the problems. So here we're given, and they introduce all the parameters, like the Planck constant, everything. And so can you just go to the next one? I don't want to read all of it, but you start like kind of like with some things that students can probably get from the problem. So what are the dimensions of the Hubble parameter? And then, okay, let's define something. Let's look at the critical density. You want to find some expression Then you're working on these dimensionless parameters. Yeah, you're finding some certain relationship between them. You can go, I think, to the next slide. And I'm sorry, I'm going a little fast because I know there's a lot more people want to talk about. So yeah, and then just builds off this initial equation, and then we're talking about like and you're learning a new concept, this fluid equation. How does that relate to things? Yeah, so I think this is like a good just overview what the problem is. And I think we can send you, especially if you're starting, I don't think all the past Olympiads are online. We can easily share with you all the Olympiad problems. Yeah, I think it's good. We can keep going. And so this one, as we kind of mentioned a little bit, from 2022, so it's more recent Olympiad, we have a junior, so it's for slightly younger students. And I really like this problem because you can kind of see like the impact of a host. Like, for example, I didn't know much about that Nepal has a unique time zone. And so in this problem, you realize there's a unique time zone. And then you relate something to it. Okay, knowing that this Mount Gorishinkar is about 105 kilometers due east from Kathmandu, estimate Kathmandu's longitude, and then you relate the time in Kathmandu and in India, in Ranchi. So it's just like a nice, cute way to, like, for students that, you know, first time are visiting Nepal, to learn more about Nepal from astronomy perspective. But also, yeah, it's just also a nice astronomy problem. So I really like this kind of creative problems. And then, as kind of Greg mentioned, like the unique part about IOAA is this observation part, which I still find it's awesome. And most of the time, it happens at night, and unfortunately, sometimes it can be cloudy. So you have to be a little creative so in certain years, hosts have come up with other solutions to still use a telescope, but not rely on the night sky necessarily always. And so here we have an example from 2022 where it was cloudy in the end. So like through a telescope, you could see an image of something, and then you had to realize what was that, and you had like 30 seconds per telescope, and then you mark which telescope was showing what. But that's just part of the observation, the kind of this night sky. But maybe you can, Aniket, next slide, sorry. But there's also like a daytime observation where we're testing students and their knowledge of sky maps and sky charts. And again, I really like that, like for example, in this 2011, where again, you see a little bit of history coming through the problem, right? Like it is, in the end, you need to figure out on this sky map, on the right, you need to find these constellations, you need to label them, but at the same time, you're told a little bit of history, and when these constellations actually became recognized by IOAA. Okay, and then this year, similarly, like in data analysis, we had, and I didn't show the data, but basically the students were trying to reproduce Shapley's experiment, which he did about a century ago when he looked into this distribution of globular clusters in the Milky Way. And so it starts, again, I'm not showing that the data, but yeah, we can go to the next slide. But you start like kind of like easy, like you're given certain data, you need to compute from one coordinate system into the Cartesian coordinates. Then from the data, you're trying to estimate the distance from the sun to the center of the distribution. And then you're supposed to do some sort of histogram. So this is where that little statistics comes in. So you're trying to distribute whatever the data you got into 5 bins. So you're sorting your data and trying to break it out. And then on the next slide, after you make the histogram, you're kind of given some data, right? Like how are you supposed to use these histograms? And then you're trying to figure out in which bucket does this your analysis come in. So it's like a nice way to use real data and test like a classic experiment. Okay, and I think from now, Aniket is gonna tell a little more. Sorry.
Hi, so I'm back. Thanks, Natasha and Greg. So just the last few slides on some of the common questions which you may have, and we'll take questions after that as well. So first question typically is how to join IOA. So as we have already said, we are always ready to welcome new countries. First, most important thing, you have to identify who will be the team mentors and define some selection process, how you will select your students. And it should not be like some mentors are ready for this year, but they are not available after that. And there's complete no transfer of knowledge about what happened when the team went for the first time in IOA. So there should be some continuity, which we always like to have. For next year, the dates to watch out would be January 2025. We expect a pre-registration. That means that time you have to tell us that you want to come, inform what is your probable team size, and name of the primary person who would be contacted for all the further details. And then you need to send full registration that we will create a form and you will have to give all details in that form. Full registration, which includes names and passport details of all participants, say around by 15th May of 2025. So people always ask, is it necessary to organize a National Olympiad before participating in IOA? It is not necessary, especially if you don't have a government support. I know it is difficult to conduct an exam nationwide. So in the initial years, it is okay to have team from just one city or one school. Also, we have accepted in some cases, but the National Olympic Committee should try to expand to the nationwide competition in the subsequent years, so that they give fair chance of selection to all students in that country. Sometimes we are also asked, is it necessary for all team members to hold passport of the country they're representing? Again, in most cases that will be true, but there are also countries where there is a lot of immigrant population, and hence many long-term residents of that country may not hold passport of the country. So, but they can still. US is one example. So there may be some students representing USA, but they may not have US passport. The other reverse may also be true, that some students may hold a citizenship of your country, but they are presently living abroad for because their parents are stationed abroad or something like that, and you want them to represent your country. Even that is accepted. We can work out details separately, but in principle, we are flexible about these things. We just discourage students to try for 2 different countries in same year. Sometimes we have got requests from multiple groups from same country that they would like to send teams from IOA. In such case, our general approach has been that we ask both the groups to show some kind of proof that their group is authorized by their national government to send a team to IOA, and whichever group can get that letter of support first will be recognized. For the teams which are already participating, the existing team leaders who are members of the international board automatically get invitation for the next year. And so we continue with the same leaders unless there is a strong reason not to continue. So this year, few of the new countries asked, is it allowed to collect some participation fee from participating students? We understand that not all countries get support from government. So, and organizing national competition requires some expense, and there may not be any funding support to even travel to the host country for IOA. So many countries, or not many, but few countries do ask students to pay for their own travel. And there is also always some registration fee charged in the first selection round. So all this is fine. We just discourage people from making profit out of this entire process. As far as they're doing it without any profit for themselves, this is fine. If you're starting a new team, how to guide them? Many of you would have taught a first undergraduate course at a university. Typically, the syllabus for IOA is similar, but tailored to the physics and math skills of the high school students. So we may not go deep in differential equations and start deriving stellar physics equation, stellar equilibrium equations based on that. But roughly, those are the phenomena, and the qualitative level, at least the physics behind them, students should be aware of. For the observation round, best would be to take help of your local amateur astronomers and train students with their help. And plus, there are a lot of e-materials available on internet which you can make use of. Some people asked us, can IOA help in training a new team? We can certainly have multiple meetings with you if you want to understand how training process may work or how to prepare a team. And some of the team leaders may have time at their hand to even participate in your training and help you with training in the first couple of years. So we can get you in touch with those team leaders. That is definitely possible. So with those questions, we will stop sharing. As is mentioned, the next IOA will be in August 2025 in Mumbai, India. And we all hope to see you there. If you have any questions, write to us, and we can also take questions now. Thanks. I will just stop sharing and let's see the questions.
Yeah, so there are a few questions in the chat that maybe, but yeah, I guess if anyone wants to also say something, you can maybe raise your hand or just start speaking.
Yes, this was great. Thank you so much to all three of you. And I think the chat was really very active. So I think most of the questions you replied, they were replied in the chat, no? Well, there is a last question, if any of you would like to reply on that, from IOLIT.
Yeah, I'm just replying. I think I'll post the link to the syllabus rather than trying to discuss it all. But yes, we have there's a link to the syllabus in the chat, which you can look on the web page, and that describes the topics that are involved. And there are planetary science topics there, and also sort of space science topics there. If you go through the past papers, you'll find that there have been questions involving space technology, maybe satellites, detectors, other things. A lot of these things can be used as the basis for an astronomy or astrophysics question, just dressed up as a planetary science question or a space science question. So the topics are definitely there. In that it's not, and also some of these other events, like for example, the Latin American Olympiad, for those people from Latin America, maybe that has a bigger component actually of the space sciences than IOAA does, but there is some. So hopefully that answers that question.
There was a comment from Milan that I found really quite interesting, to maybe create a WhatsApp group or similar. Actually, and then bring people together. There is something that we are planning to do under the Division C. We will open soon Slack, which will be totally open to the community. So not only, I mean, in principle for the Division C members, but anyone will be able to join to that. And that Slack channel will be there to a bit share all different activities that are running under the Division C in education, outreach, heritage in astronomy, but then also to give more visibility to the activities that are there and to involve people more to join the activities. So there will be under that Slack, there will be channels for all different commissions, C1 on astronomy education as well. And then under that, we can create definitely a channel for the Olympiad as well. So that is something we are planning to launch that with the steering committee now before the end of the year. So then that will be one definitely, let's say, more public way channel to communicate. But maybe, under the team of the Olympiad, you can discuss to create a WhatsApp group, and then from the Division C, we can try to, distribute the message and through all different networks so that people can join. So you can just, Aniket, Greg, Natasha, you can just let us know, let us keep in touch. And if you decide on creating that, I think it's really a good idea.
It's true. I think somebody from the Ethiopian team was also asking the same thing. They want to have some sort of community support and like
Yes.
there should be some way to discuss. Yes, so that's something we should do. Mm-hmm.
Yes, I think that definitely that would be very helpful, especially for, countries that are starting from zero and, trying to join for the first time. And I think
Absolutely.
it would be really helpful.
I don't know if Majd, you're trying to say something, but you're muted.
I don't see any hand.
You seem like you were speaking.
No, but what I will say, first, thank you. It's a very interesting opportunity. I listened to you and all, and really it's a wonderful thing. We have in Israel Olympiad here in the local country, and also I take students for Space Center in Europe and Turkey, and I like to arrange some and help to do that, not for the competition, for to learn and to see other people and learn what all learn. But I want to learn and study everything and send you questions. You have a set, internet set.
Mm-hmm. Sounds good.
I will send you a mail.
Yeah, sounds good.
Sure,
Great,
sure.
thank you.
Sure.
Yeah.
You
Thank
have,
you.
Majid, do you have, you do have all the contacts?
I get a message in the WhatsApp, but if you have
So
if you can send me, I will thank you.
Yes, maybe if you would like to put in the chat, Natasha, Greg, Aniket.
Yeah, we had it as a last slide. Yeah, but we should.
Any
I will
email,
send you.
you can get in
Yes,
touch.
thank you.
Thank you.
No, sorry, I did the wrong word. Let me check. Sorry. Okay.
Okay, good. So I can see. So please check the chat for emails of all three speakers. So for any questions that you can get in touch. I had a few questions as well. One question is related with the language. So, what are I suppose everything is, all the questions, everything is in English, no?
Yes, it's in English, but I think that was maybe kind of said quickly. That's one of the jobs of the team leader. So if the students also, not if they have a local language that they talk in, they usually, that's part of the job of a team leader, to translate to the students. So
Yeah,
some
so
some countries you don't translate because anyways.
yeah, so all the questions will be translated into the local language of the students by the team leaders. So obviously countries like the USA, UK, India, maybe some others won't translate because they use English natively, but there are translations in Russian, Polish, Hungarian, Serbian, Croatian, Persian, Arabic,
Yes.
Mandarin,
Chinese,
yeah.
Korean, etc.,
So
etc., etc.
what it also means is that the questions are designed in such a way that solutions are independent of language. Means solutions are mostly in terms of equations and numbers.
Okay, that was my another question. No, when they answer, I mean, do the students use their own? Yeah, because since the time is limited, of course, the language matters. No. Okay, great. That's good. One comment is, well, two comments maybe. Something that maybe we can think about. I mean, there was actually a question from Buzani, our colleague from South Africa. I know that South Africa is putting really a lot of efforts to establish the team. Morocco as well in Africa. Ethiopia is also putting an effort to establish the team. So hopefully in the future we will have stronger African participation, because the capacity there is really amazing and we have a lot of students that are really motivated, highly motivated. Buzani was asking about the online version. I mean, definitely funding is a very important barrier for the low-income countries, and to actually get even the support from the government to fund for all the travelings, starting from the plane tickets and everything else. No, having maybe the online version in the future, it's really something that you would like to consider, so that somehow we can improve the participation of the students, countries, at least for for the maybe first few times. I suppose that there are ways that can be done in a safe way. I don't know, it's something to really maybe explore and to think about it.
Miriam, so what we mentioned earlier in the presentation, the IOA is not just about competition. One of the big parts is the students getting chance to meet other students from with similar interest all over the world. And unfortunately, that cannot happen in the online version. The 2 years when we had to do the competition online because of pandemic, we realized there are a lot of problems also doing it in an online way, because different countries will use very different methods to conduct the competitions in their own country. And then it becomes very difficult to say that all participants participated in the same way. So
even
there
just
are
the question of time
challenges.
zones. Even just the question of time zones, how do you deal with the fact that, if you want to have everybody running at the same time, then some students are doing it at 2 in the morning and some students are doing it at 10 in the morning. It's logistically very difficult to do. Now, we did do, during the first year of the pandemic, we did do something we call the GECA, Global E-Competition on Astronomy and Astrophysics. It has a different name because we weren't sure how well it would work. I posted a link in the page. It actually worked better than we expected. And this was basically an online IOAA. It just has a different name. And we would be very happy if somebody wanted to organize something along those lines, to use that as a model and maybe improve on it. I think we would be happy to help with guiding that. But I think for now, at least, our focus is to keep the IOA in person, just for the social aspects, for the cultural aspects, for the interaction, and for some of these logistical aspects like time zones and other things. We do have mechanisms in the statutes following the pandemic for online participation, but the consensus of all of the participating countries so far has been that they prefer to be there in person if at all possible. So we probably won't go back to an online version unless there is another major global issue like the COVID pandemic. But if somebody wants to try and do that, if somebody would like to do say a Pan-African global Pan-African e-competition along the lines of the global e-competition, by all means, we'd be happy to give advice and our experiences of how to make that work. And there's nothing, we have no problem with things running in parallel to IOAA. More astronomy, better.
Yeah, for example, in the US, after a pandemic, now we only do online selection process. So the local, because US is kind of similar, it's a huge country. A lot of people are very spread out. So we just we do the online, and that's how we select the team.
But that's that's excellent point, and I think for Africa to, I mean, we can really through the AFAS, the African Astronomical Society, maybe organize in 2025 that, so that we actually give that as a like just competition in astronomy for all African countries, whoever wants to participate, so that we can really a bit initiate with the idea. And then hopefully go from that to more in person. So let me comment that to the to the executive committee, and we will definitely let us keep in touch. I think that's really an excellent idea, and that's something that through the office we can definitely do. We can organize. Yeah. Great. I don't know if there is any other question. We are running already for 1 hour and a half, and I think it's been really great. Any other final question, comment?
Do you collect emails of the participants here, or you just want us to contact you if we are interested?
You can leave, if you would like to leave your email, so that if there are any updates later on that you are included in that email list, please leave your email in the chat, because this is a recorded session, so we will have the copy of the chat as well. So we can then definitely get, the team from the International Olympiad, and then from the Division C, we can then definitely get in touch with you. I think there is a question from Giovanna. Giovanna, go ahead.
Yes, hello, hi. Thank you very much for the presentation. I am from the Netherlands. Now, my kids are in high school and they participated in the Math Olympia, and they also participated in the new Artificial Intelligence Olympia. My son even won a bronze medal for that. But there is no publicity at all about Astronomy Olympiad. In their school, that it is an international school, there is really nothing about that. And I have friends who teach in high schools here in the Netherlands in different cities, and they are not aware at all about this. And this is the Netherlands. So I have the impression that as astronomers, probably we should try to do a bit better about the awareness about this, because for the Math Olympia is so popular and everybody is aware about that. Also for the Physics Olympiad. So I think it is our responsibility in every country to do a bit better. And I'm just wondering if there is some, for each country or for each region, and a local reference point. For example, if I want to do something about the Astronomy Olympiad here, who is in charge of this? Who should organize? Or who should be in charge to spread the news in the schools? It is at the IU level, it is at the local level.
You can be the contact. Last year, 2023, some people from Netherlands actually contacted us, and they wanted to bring a team, but finally they decided not to. I don't know what exactly happened. We can share their email IDs with you as well. But if there is nobody else who wants to do it, you can be the local in charge, and you can bring the team to Mumbai in August.
Okay,
also-
I mean, let just us know what we can do, because, you know, it is in the interest of everybody to implement it, because the kids love astronomy, and it is a very nice way also to make women, you know, female in STEM more interested. I think it's a lovely way to do it. Thank you.
So just to add, on the IAU level, there are the National Astronomy Education Coordinators. So they should be, it obviously varies from person to person and country to country, but they should be plugged into, you know, distribution channels to distribute information to schools. So one of the things that in your country, in any country, if you want to reach schools with a project like this, would be to talk to the National Astronomy Education Coordinators, and hopefully they will support that. I realize that can be varied, but that would be a group to reach out to as well.
And I guess we also have a session on Wednesday. So if you know anyone who would be interested in listening to this, maybe you can also pass it along. We'll do the same thing, but it's just for others.
Yeah, so if you have any other colleagues who you think should be listening to this, ask them to join the session on Wednesday at 11 UTC, right?
Yes.
Yes, exactly. Yes. Okay, great. So I think we can stop here. It was really a great session, and we got really quite diverse participation from Morocco, from Serbia, France, Romania, Taiwan, Indonesia, Israel, South Africa, Ethiopia, Tanzania, Netherlands, Spain, Portugal, Brazil. I think I mentioned all. Beside the speakers, the countries of the speakers. Thank you very much, Aniket, Natasha, and then Greg as well for your time and for the seminar, and for all your for all the work that you are doing with the Olympiad. That is really great and very inspiring and important that we have. And many thanks everyone for joining. So hopefully you found it useful, and hopefully we can with this increase the participation. And then, I mean, what we all want to have more students inspired in astronomy, science, purchasing their studies, and then sitting in a few years here with us. Well, thank you everyone. And then on Wednesday, Aniket and Natasha, Greg, see you on Wednesday.
Thank you. See you
Thank
soon.
you.
So we will be
Bye.
sharing recording after Wednesday session with all the information that is there.
Thank you.
Thank you.
Okay.
Bye.
Bye bye.
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 Thank you.
Thank you very much.
I have to stop recording, right?
Yes, I think I don't know if you have to stop recording. I think